What makes planetary rings' evolution so baffling? Imagine a delicate dance of countless particles orbiting a planet, each one influenced by gravity and collisions. Now picture these rings changing shape and structure over millions of years, yet some features stay remarkably stable. This puzzle has scientists scratching their heads for decades. Planetary rings are not just pretty sights in the sky. They are complex systems that challenge our understanding of how celestial objects evolve. And like solid planets or moons, rings are made of tiny dust grains, icy chunks, and rocks, all moving in a fragile balance. Their formation and how they last so long are still mysteries. One of the strangest things is how some rings keep sharp edges or confined arcs. These structures should spread out over time because of gravitational forces, but they don't. For example, Neptune's rings have several arcs that seem to stay put, even though gravity should disperse them. Scientists think unseen, shepherd moons might hold these arcs in place, but no one has found these moons yet. This makes the stability of these features even more puzzling. Rings also vary a lot between planets. Saturn's rings are wide, bright, and mostly made of water ice. Jupiter's rings are faint and dusty, created from tiny particles knocked off small moons by space debris. Uranus's rings are narrow, dark, and have unusual red and blue colors. Each set of rings looks different, which hints at different origins and ways they change over time. This variety suggests multiple ways rings can form and evolve, but scientists are still trying to figure out the details. Another surprising fact is how short-lived some rings might be. Saturn's rings are believed to be only about 300 million years old, which is young in cosmic terms. They could disappear in less than a billion years. This means rings are not permanent features but rather temporary snapshots in a planet's history. This raises questions about how new rings form, whether from moon collisions or debris captured from space. Rings are not just around big planets. Some small bodies like dwarf planets and even asteroids have rings. For example, the dwarf planet Quasar has a ring, and the exoplanet J1407b has rings that are much larger than Saturn's. These discoveries challenge old ideas about what conditions are needed to create rings. They show that rings can form in many different environments, making their evolution even more mysterious. In the end, planetary rings are baffling because they come in so many shapes, sizes, and lifespans. They are natural laboratories for studying how gravity, collisions, and planetary systems change over time. Many questions remain about how these beautiful features form, stay stable, or fade away. Did you know that by studying rings, scientists can learn about the early days of our solar system and even other planetary systems? These cosmic curiosities keep fascinating us with their secrets.